All right, what's the difference between speed and velocity? We're going to go through questions in preparation for a quiz that you will take. So this is going to help you prepare for a quiz. What's the difference between speed and velocity? We've talked about this before. The difference between speed and velocity is the fact that velocity has direction while speed has no direction. Okay? So speed is a scalar while velocity is a vector quantity. The kind of speed you read on a speedometer, what is that? Is the average speed? Is it instantaneous speed? Is it changing speed or constant speed? Of course, that's instantaneous speed. That's the speed at that particular time. And that keeps changing depending on whether you accelerating or you stepping on the gas pedal more or you are stepping on the brake. Distance travel is equal to average speed multiplied by, again, that's very tricky, okay? If you remember the formula for speed, then you should be able to answer this question. Multiply by time. So we said average speed is equal to total distance travel divided by the time travel. So if you rearrange this formula, you see you realize that the total distance travel is equal to average speed times travel time. So constant speed in a constant direction is constant velocity. Okay? Because when you add direction to speed, it gives you velocity. A hungry bee looking directly ahead sees a flower in a 5 meter per second breeze. When it gets to the flower, how fast and in what direction should it fly in order to hover above the flower? We've seen this question in class. The bee should fly 5 meters per second into the breeze. When a car rounds a curve, it is moving uniformly, it is accelerating, it is in a rotational equilibrium. We've seen this in class. We said even if it is moving in a circle, even if the speed is constant, the direction is constantly changing. So because the direction is constantly changing, this object is accelerating. Because acceleration means direction is changing, it also means that the speed might be changing too or increasing. When a bird flies 8 kilometers per hour in an 8 kilometer per hour headwind moving against the wind, the speed of the bird relative to the ground is a bird. When a bird flies 8 kilometers per hour, right, in an 8 kilometer headwind, so remember, moving against the wind, okay? Headwind, it means it's moving in the opposite direction. So the speed of the bird relative to the ground is zero. And if it turns around and flies with the wind, so its speed relative to the ground now is going to be the speed of the wind plus the speed of the object, right? Because they go in the same direction. But if they go against one another, remember when we're calculating net force, the effect of the headwind is going to cancel the effect of the bird. Okay. So if you have a motor vehicle, it increases speed by 4 kilometers per hour each second. Its acceleration is, so acceleration is simply speed divided by time. Okay. So 4 kilometers per second each second, 4 kilometers per hour each second. So that is just going to be 4 kilometers per hour per second because you divide that by 1 second. When a ball rolling down an inclined plane gains 4 meters per second each second, the acceleration is same thing, right? You divide the 4 meters per second by 1 second, and that's why it gives you 4 meters per second square because it's 4 meters per second, right? Per means divided by. A body undergoes acceleration whenever there is a change in its speed, okay, or velocity. So all of the above, because if speed is changing, if velocity is changing, if direction is changing, the object is accelerating. Okay, it's the same thing. A ball initially at rest rolls along a pair of equal length track A and B, as you can see. It will roll faster when it goes through track B, right? So because those ones will give them an acceleration. So remember, each time it's changing direction, it is having an acceleration. So this curve path is going to make it change direction, and changing direction will make it accelerate. A ball rolls along an equal track length A and B due to increased speed in the dip. It will have an overall greater average speed on A. Okay. A ball rolls along equal track A and B, it will reach the end of B sooner than A. But we've already answered the previous question. If here we have a greater average speed, so a greater average speed will make it reach faster. So A will have a greater average speed. So greater average speed means it is going to reach to this end before this other one. If you drop a boulder from a tall cliff, as it falls, it will gain. We've said that it's going to be, if it's a free falling object, then it's going to gain 10 meters per second per second. After being dropped from the top of a high building, a free falling object has a speed of 30 meters per second at one instant. Exactly 1 second earlier, its speed was obviously 20, because earlier, remember, if it is having 30 meters per second, remember that as soon as it's dropped, and because it is a free falling object, it is going to have an acceleration of 10 meters per second square. So if it that acceleration was caused by gravity, so initially its speed was 20 if it is having a speed of 30 after free fall. Toss a ball straight upward, and each second on the way to the top, it will lose. It will lose 10 meters per second. So when you toss a ball upward, what happened? It is going against gravity. It's not like dropping the ball. When you drop the ball, it's going towards gravity, towards it, acting in the force, acting towards the force of gravity. But when you toss it upward, gravity is going to slow it down by the same value that it will accelerate it if it was falling. So if you send it up, it is going to be slowed down by a value constant 10 meters per second. When a ball is tossed straight upward, the direction of its acceleration is upward also, downward, actually horizontal. Obviously, the direction of the acceleration is downward towards the earth. The longest that anyone in your school can be in air when jumping straight upward, landing at the same place, is less than 1 second. Even basketball legend Michael Jordan had a hang time of less than 1 second. It's difficult to jump and remain in the air for more than that. All right, so that is that for this section. Hopefully, you're able to take down your notes and write down this question as we are going over.